Welcome everybody to the DeFi Security Summit. Today we have two titans of industry within the liquid staking world, Eugene and Dimitri, who are going to talk to us about um, some of the things that they've been working on. So first we'll hear from Eugene Mammon. He's a Lido protocol contributor. Lido is the issuer of the largest decentralized liquid staking token, stETH. Eugene, I'll let you take it from here.
Yeah, hello everyone. Thank you for having me today. I want to start the presentation shortly. Let me share a screen first. Okay.
Oh, just a quick reminder to everyone, we do have some time for Q&A after this, and so if you could please use the Q&A box below. It should be part of the Zoom web conference to post your questions. And we'll do our best to pick out the best ones and ask our panelists.
Okay, thank you. Shall I start then?
Yep, let's do it.
Okay. So once again, I'm from Lido. I'd like to talk today about the aspiration for an unmanned protocol. It's a concept that lives inside Lido. So I'm Eugene, Lido core protocol contributor. I've been participating in the protocol development for 2 years and participated in the largest so far protocol upgrade, Lido V2. So today I'd like to start with a short explanation what Lido on Ethereum is, what is unmanned operation, how we define this concept. Then I refer back to previous DeFi Securities Summit topic about most important security measure. Moving forward, I'll explain how we approach to core unmanned operations and what are the iterative improvements for the protocol have been introduced and anticipated further. Last but not least, there are various takeaways concerning DevConnect week happens quite soon. So first of all, what is Lido on Ethereum? It's liquid staking protocol. The protocol acts as a middleware connecting users who have Ether and node operators who are able to run validators, participating in Ethereum consensus. Nowadays, protocol TVL is more than 8 million Ether. So quick fact list is that protocol provides ST assets. It's STF and its roped version. The protocol has withdrawal mechanics implemented via in protocol queue. It's a reason for having another token, unSTF. It's an NFT position representing you inside the queue. The withdrawal mechanics was brought to the protocol together with Lido V2 upgrade, and another significant feature was brought. It's staking router, composability solution allowing onboarding diverse validator subsets. Last but not least, all of the protocol upgrades, changes, parameter tweaks, and tunings are performed via explicit on-chain DAO voting process. The governance token is LDO. So let's start with the Lido DAO topic briefly. Recently, Lido DAO stepped into new framework for goal settings and objectives. It's called Goose. It's guided open objective setting exercise. Basically, it consists of goal setting framework and its cadence following. One of the important parts here is that the DAO ratified submission of Hasu, its Lido advisor, who also provided strong focus on protocol security to achieve Lido DAO goals and be and be and be Ethereum decentralized liquid staking protocol. So I'd like to introduce unmanned operation concept. It's our security guiding principle. What does it mean? It means that unmanned consists of two parts. Firstly, we remove trust whenever it's possible, and if if it's not possible, that we strive for remove it iteratively. The second part is removing and avoiding any manual operations, any sidecars that requires explicit maintenance, because otherwise it could become tech debt and should be reevaluated, revisited in the future. So why we talk here about unmanned operation, not ossification? Because ossification is quite common concept here. Unfortunately, ossification being the ultimate option isn't viable short-term, even mid-term for the liquid staking protocols, because underlying network's evolution, I mean, both execution layer and consensus layer still happen. And moreover, there are various discussions about consensus layer changes, staking mechanic changes. So everything is moving, having so many moving parts, not practically viable to achieve ossification. So what are we striving for is unmanned operation. I'd like to refer also to the previously disclosed and discovered in-depth security process for the Lido upgrades, and not only upgrades, but actually all of the infrastructure, staking widgets, lending, whatever is made by the Lido contributors. So it is a talk by Eugene Pshenichny that he gave on DeFi Security Summit this year. The key point of his speech was that the contributors team is the most important security measure. But how come? I mean, we started with unmanned operations and once again talking about people. So the idea is quite straightforward. Basically, people who work for the protocol and on the protocol mechanics strive for two things to happen. First of all, protocol trust circle should be shorter, it should be shrinked, and the contributors team should be removed from the circle at first, and then the distance should get longer and longer. So that's it. Returning back to core unmanned operation, I would say that we can group all of the protocol flows and mechanics into two separate groups. First of all, it's primitive flows like accounting, deposits, withdrawals, and more composite flows, the whole governance topic, validator set, formation, and maintenance. So the gist of it that for unmanned operation, we should start with primitive parts and make it as unmanned as possible. So let's dive into it. For the accounting, the state of the art of the protocol that protocol balances keep updated by the Oracle committee. The Oracle committee brings consensus layer data together with execution layer data for finalizing withdrawals. It's quite a complicated piece of data delivery, but still, since EAP 4788 is around the corner with the upcoming DNConf hard fork, now it's possible, at least in short term, to deliver consensus layer data about validators' balances. However, considering current Ethereum mainnet validator set size, I mean more than 1 million indexes were allocated already. It's not practically feasible to prove every validator state. And in contrast, it could be done with data compression, where ZK field comes to play. So currently, we are looking for ZK solution. It has been granted by the Lego part of the DAO. So the idea is quite simple. We're gonna make the process iterative, not replacing the Oracle in a single shot, but instead make it gradually. Incorporate ZK tech as a safety net layer, firstly, and even further, we participate in not only with one ZK solution, but it's 3 competitive ZK solutions were funded by Lego, and to connect them together, we introduced multi-proof architecture. It's basically kind of multi-sig. So when ZK Oracle provides data about validator balances, the data should be in consensus between at least 2 of the participants. Second point about unmanned operations is withdrawals. Like I said, the protocol implements them. However, state of the art that they are semi-automated. It means that the DAO voted on policy. Exit requests are issued through Oracle. Technically, it's emitting events, and node operators monitor for these events and voluntary exit validators if they are affected. And moreover, if they haven't exited timely, they got penalized. Overall, it works, but still there is room for improvement. I mean, suppose triggerable exits were implemented, a smart contract would be able to exit late validators in a non-voluntary way, but rather defined by the smart contract. And actually, triggerable exits could pave the way for permissionless validator sets and make unmanned operation even more robust and self-sustainable. So that's why it's an important topic, I suppose, for making withdrawals truly unmanned and sustainable in long term. But there is an interesting fact that when developing withdrawals, we stumbled upon various security considerations that not only new mechanics are presented with Chapella hard fork, but also the protocol was hugely revamped, and to overcome all of the concerns and maybe paranoid activity, we also found a solution here. It's quite simple thing. It's self-deprecation mechanics that able to pause withdrawals. It's like one-time panic button, having only limited impact, both by duration and by involvement into the core protocol. And once again, why it's good and why it's still unmanned. Gate seals have self-deprecation mechanics that prevents perpetual control over the protocol. So it's a kind of isolation solution for things that still can be considered for emergency, but should be left unmanned long term. Okay, and last but not least, there is an example of deposit operation. So previously deposits were permissionless in Lido, but once front-running vulnerability was reported, deposits are performed by a guardian committee. Guardian committee basically assigns blocks state root of the deposit contract, and a single honest actor of the committee can pause deposits if front running detected. So it's an example when we previously had a purely unmanned solution, but due to vulnerability, decided to solve it with committee and midterm solution. Yeah. If I speak about all of the iterative improvements that have been made for the protocol, they are all presented in our scorecard. It's a self-assessment measurement where all of the security topics are presented, I believe. Not only security, but actually it's about decentralization. But if we speak about decentralization, we just can't avoid speaking about security. And my takeaways here, basically, like I pronounced in the beginning, follow Lido on DevConnect. There are plenty of activities. I'd highlight the following. It's a speech by Eugene P. Planning the future of Lido. It's a part of Staking Summit, November 10th. Gate seal architecture will be discussed further. And there will be also ZK Oracle panel describing the ZK solution for delivering validator balances data. And quite recent topic for Lido. I mean, not maybe recent, but quite burning topic. It's dual governance and community staking. So please keep in touch and follow for more activities. And I suppose you might find many more interesting information here. That's all from my side. Thank you.
Thank you, Eugene. We're going to save questions till the end. We'll have a dedicated question and answer session. But next up, we have Dmitry Tsumak, who is the founder of StakeWise. StakeWise is a smart contract-based solution to help users stake Ether and compound their rewards over time. Dmitry, I'll let you take the floor.
Thank you, and hi everyone. Yeah, I'll just share my screen in a moment. Can you see my screen?
Yes.
Awesome. Yeah, let me introduce to StakeWise if you haven't heard of it before. StakeWise is a liquid staking protocol. We've been live since early 2021. as of now, we have 100K ETH staked and plus 75 million in liquidity. Currently, we're running on StakeWise V2. So initially, we started as a single node operator, liquid staking protocol. In V2, we upgraded to multiple node operators so that anyone can apply to become an operator in StakeWise protocol. And now we are in the process of transitioning to the new version, which is StakeWise V3, where anyone can run validators, can run their own liquid staking business, or they can run validators for others as well. So in today's talk, I will give you a bit more insights on how StakeWise V3 works, what components it has, and what technical difficulties we had to solve to achieve a decentralized protocol that we have in V3. So our V3 protocol is based on two layers. One layer is called Vault, and another layer is called liquid staking protocol, liquid staking token, OSIF. So vaults are smart contracts that contain all the functionality required for staking Ether, like accepting deposits from the users, registering validators, processing the exit queue, and many other things that you need when you run your staking operations on chain. So, and vaults can be deployed through the factories. We have as of now 4 different factories that can deploy different flavors of vaults. I'll tell a bit about that later. But also, when you deploy the vaults, you have different parameters you can choose, and you can either provide, you can run staking for others, you can do staking for others, or you can also run your validators for yourself and have access to the liquid staking as well. So another layer is called OSIF, and this is the token that you can mint out of any vault. Of course, there is a slashing risk that you face when you mint the OSIF token. So OSIF is minted not 1-to-1, but there is it's over collateralized. So basically, you can't mint for every ETH you stake, you can't mint one OSIF, but you mint with a certain percent. It's very similar to how DAI works, where you have vaults where you can lock your assets and you can mint DAI on top of it with certain collateralization ratio. And in our case, it's quite similar here, but instead of locking different assets, you can only lock Ether that is then staked, and then you can mint OSIF on top of it with a certain collateralization ratio, and then you can use OSIF further in DeFi to utilize other opportunities for your stake. So as of use cases here, vaults there are different flavors of vaults. That's thanks to our architecture that we achieved on our smart contracts, where we have multiple modules and they can be combined in different types of vaults. So this way we are able to deploy private vaults, vaults with ERC20 tokens. So if you want to have your own staking derivative, you can deploy that vault through the factory. And also you can have both. You can have a private and ERC20 vault. So in that case, you're running, let's say, institutional staking, where you want to KYC people who can stake into your vault. And on the other side, you have, let's say, a token that you can use outside to integrate. And that's fully in a permissionless manner. It's anyone can deploy the vault through the factory and select the features that they want to have in their vault. So yeah, and some more examples from here is that with like StakeWise V3, you can create a vault, you can stake there yourself and mint OSIF on top of it. So you can run validators for yourself and at the same time have a liquid token that you can utilize in DeFi. And if you don't want to like run yourself, or if you don't want to create a vault, you can buy OSIF from the market, and it has slashing protection because it's not minted with one-to-one with Ether, but actually it's backed by over collateralized mechanism here that we use to make sure that we can protect from slashings. So yeah, this is like the OSIF itself. It accrues the value as well. It's an average of APYs of all the vaults. So every vault runs with its own APY, and an OSIF has has an average of all the vaults here. And the rewards are accrued every second, and by staking and staking, you can utilize like the secondary market to mint to actually get OSIF and utilize it further. So a bit about like the deployments of the vaults. So there are like multiple factories that deploy the proxy contract for the vault, and the vault itself is upgradable, and there is like dual mechanism for upgrading the vaults. I'll tell a bit about later on that. But here, when you deploy the vaults, there is you actually like deploy the proxy and connect it to the implementation contract that was previously already deployed and is on chain. So there are multiple modules that we have. There is like Vault Admin. This is the module that is responsible for like making sure storing the admin of the vault. The admin can update the parameters, like for example, setting who gonna have the possibility to whitelist the addresses, or update the deposit data required for registering validators, and some other parameters as well. Vault enter exit module is responsible for accepting the deposits from the users, and also like it has the functionality for withdrawing the funds from the vault as well. The OS token is the one that allows vaults to mint OSIF. So it has all the functionality for checking whether the amount of OSIF you want to mint is not larger than the amount of ETH that you have staked. So it checks. It's similar to, let's say, if you lock ETH on DAI vault and mint DAI. So when minting DAI, it makes sure that you have enough ETH locked. So Vault OS token module is responsible for that. Vault immutables are just like the module which has some immutable values stored in there, used across the other Vault modules. Vault validators is responsible for storing the data required for registering validators. So for example, if you created a vault, you allocated validator keys to it, then when spinning up the validator, that module makes sure that actually the validator that is registered right now was previously whitelisted by the admin of the vault. So basically, someone else cannot register the validator for your vault. Vault ETH staking encapsulates the functionality specifically for ETH staking. So we also run like on Gnosis chain, for example, and later if we bring V3 to Gnosis chain, we will be able to have like GNO module that then can be used in conjunction with other modules to provide staking here. So then Vault fee are responsible for the fee, MEV module responsible for MEV required functionality. We have like a smoothing pool as well, and we also have like you can also collect MEV rewards only for your vault, which we call like on MEV escrow. So they're based on your decisions during the creation of the vault, the different functionality is used. If you want to have your own vault token, you can that vault token can be used here. And also like the vault version is for making sure that upgrades are done correctly. So there is like a dual governance upgrades that we allow to do for the vaults. I'll tell a bit about later, and vault whitelist in case you want to whitelist like users who can stake. And vault state is basically the module that contains the exit queue functionality. So whenever user enters the exit queue, waits for the assets to be unstaked and withdraws, that module does that, and it also is responsible for minting shares, burning shares in ERC for 626 fashion. So that's like the basic modules, and by having them, we can combine. Let's say if we add the vault token module, it allows us to have like ERC20 in our vault. If we add like whitelist, it allows us to have like whitelist the users who can stake. And also, like in the future, we will add more modules, and we will try to create like more different flavors of vaults, so that all the different groups of users like DAOs, solo stakers, institutional stakers can actually benefit from creating a vault through the factory and running the staking operations for themselves. One of the key part for us was to make sure that we can exit the validators when they get registered. So that's the difficult part before the on-chain exit submissions will be enabled. So for now, what we do is that we have a Oracle's DAO that is responsible for submitting the consensus rewards, bringing them from consensus to execution, but also they are responsible for collecting the exit signatures of the operators before the validators get registered. And that's actually the tricky part here, because you have to, in order to create the exit signature for your validator, you must know the validator index before. And we can't kind of allow to register the validator, then expect operator to provide the exit signature for us. So in our case, we collect exit signatures before the validators are registered, and this way, every time any user wants to exit specific vault, Oracle's DAO will publish their shares of exit signatures, making sure the validator for that specific vault will exit, and the user will be able to collect staked assets from that vault. And the way we do that is that we pre-calculate the index based on the events from the Beacon Chain contract. And we know exactly when there is like a deposit route, what index corresponds to specific deposit route. And this way, like Oracle's sign, when they verify like this is the current deposit route of the Beacon Chain contract, and this is the validator that gets registered, it's gonna get this index. So they pre-sign the message they sign the message allowing the operator to register the validator, and then contract verifies that enough Oracle signatures were collected and allows the operator to register the validator. And this way, like operator runs the validators for the vault, and Oracles are responsible in case, let's say, operator doesn't want to do that themselves. Oracles will monitor the assets that want to exit from staking, and then decrypt the exit, like shares of exit message, and publish that to make sure validator exits from staking. So yeah, that's one of the important parts for us to make sure that like exits are controlled by the protocol. Another interesting part that I was mentioning before is the dual governance. So one thing what we have right now in V2 is that DAO decides what to upgrade to. So in that case, like if we want to release a new version, we do the DAO voting, and in case it's positive, the on-chain transaction is submitted and the contracts are upgraded to the new version. But in the new protocol, we wanted to make sure that both the DAO and the vault creators, or maybe if it's a DAO who's standing behind the vault, that have to agree on every upgrade of the contract. Making them immutable was like not an option for us because Ethereum constantly evolves and there are like new things added or changed. So the vaults have to adapt to the changes of the Ethereum. So we want to make sure that we will constantly improve and let's say comply with the changes on the Ethereum side. So the way it works is that DAO registers a new implementation for a specific vault type in the vault's registry. Then, like in vault's version module, there is a check that the upgrade function is called by the admin of the vault, and the implementation contract is whitelisted in the vault's registry. So this way, like DAO adds to the vault's registry, and the one who can upgrade is the admin of the vault, and then yeah, so the vault upgrades. It also has some additional checks that the vault type is the same, so you can't, let's say, upgrade from ERC20 vault to non-ERC20 vault, and also make sure that like you are not downgrading to the previous version. So it's always like the version is increasing, and that's thanks to like the UUPS contracts where you have authorized upgrade function inside the implementation contract where you can actually define the way the upgrades can work. So this functionality we utilized for the governance of the vault. So yeah, I think that's like some of the important parts that we had to solve for V3. There are also like some other things that we can probably chat about later, but I think that's pretty much for me for now. Thank you for listening, and I'm happy for any questions you have.
Great. Maybe we'll start with a few specific questions for the speakers, and then we have a few more, broad topics we can discuss. So I'll just start with, there's someone here, I think they're asking, Dimitri, will staking rewards in OS ETH be restaked automatically?
Yes. So like the staking rewards are compounded there. So yeah, they are restaked there. The withdrawals are automatically happening into the vaults, and then the vaults, once there is like 32 ETH accumulated, they will be restaked again into the new validator.
For Eugene, I think there's a question here about unmanned operations. Specifically, is there an expectation to create some type of monitoring about on-chain actions in order to build profiles for validators?
Well, I suppose it's not an operational concept, but a design concept that I presented. So actually, I believe it's not needed at this stage, maybe.
Yeah. Great. So I think I forgot to introduce myself. I'm Drake Evans, and I am a core contributor at the Frax protocol, and we also are in the process of sort of decentralizing our liquid staking token, Frax ETH. I think as it stands today, all liquid staking derivatives have a few points of centralization, which we touched on, specifically getting information from the beacon chain to the execution layer. And also, Dimitri talked about this as well, this idea of taking hold of the validator exit messages, which are required to boot bad validators and eject. There are a few EIPs in process to address some of these specific concerns. However, there are some people who make the argument that a truly decentralized validator set and permissionless anonymous validators actually pose maybe some threat to the health of the network. My understanding of the arguments are essentially along the lines of it reduces the cost of an attack on the network. And I'd be curious to hear, if we are working towards this sort of anonymous, permissionless, decentralized validator set, do you think those concerns are valid, or what are your thoughts? I'm not sure who wants to take it first, but I think we'd love to hear from both of you.
Okay, if I can be first, then I would start that permissionless validation is a fruitful topic, yeah, because Lido is committed to the process of improving the decentralization of validator set. Currently, it's not about like current state of that, but emerging DVT technology also helpful here. And that's why we are piloting DVT project, a simple DVT project called firstly with testnet on Holeshki, and then to mainnet with a limited share, of course. So my opinion here, my own opinion, I would say that everything new and everything like emerging into Ethereum was not only like pure black and white color, but maybe careful evaluation and a gradual process, moving from testnets and having like training wheels. Yeah, you know the term maybe from L2 papers that presented by Vitalik. So that's it from my side.
Yeah. Yeah, I think like in general, like the architecture where you have, let's say, you have one place where you aggregate Ether, and then let's say it gets distributed to anonymous validators. That's, I would say, like maybe risky, because then there is no any reputational part that takes place here, because like you really are giving out Ether to, let's say, unknown validators. But in case there is some reputational fact, maybe some validators or operators, they are anonymous, but due to the good overall performance for like many years, and maybe proving the underlying staking architecture that they have, let's say maybe they use DVT or some other way of making sure there's like no slashing, and yeah, maybe like some other things. In that case, I think it could be fine that the operator himself stays like anonymous, but then there is actual reputation that speaks for themselves. Because in the past years, we've seen like not many, but some of the reputable operators getting slashed or like losing the withdrawal keys. So that could happen, and maybe some of the anonymous validators will run pretty well, if not better than some of the reputable ones.
Thanks. I think another thing that people talk about to a certain extent is the network effects of validating, and I think I'll maybe more broadly say the economies of scale, and the idea that maybe a decentralized validator set is actually very hard to achieve in a competitive environment, because there are massive economies of scale to running validators. These end up kind of in data centers, and I guess when we think about the security risk of that, how do you guys think this plays out, and are there ways to address this? I'll let Dimitri go first, since we went with Eugene first last time.
Yeah. Well, I think like probably having a like whether that's the responsibility of the protocol to make sure they're not going like too large or not. That could be one thing. Like for example, if you like take like your liquid staking protocol and think like, okay, if all the validators in that protocol gonna get slashed, what will be like, whether we will be able to cope with the damage, or whether there will be like a way of not harming the underlying network. So like in our case in V3, we have caps that you can set as a vault. When you create a vault, you can say like, I'm not accepting more than X amount of ETH. And also we set as a DAO a cap on how much OSIF can be minted in total. And this way, like also because we are over collateralized, we need to make sure that the LTV that we have is always corresponds to the current network situation. So if we see that there is a lot of like slashings happening, or like the network becomes unstable, we will decrease the LTV so that it will motivate people to burn OSIF to make sure they not get like liquidated if they won't do that. So this way we will try to reduce the amount of stake that the protocol has, so that we always stay like right under the risk here. So yeah, I think it's kind of like it really depends on the protocol how they solve that, but of course like growing large is always considered in networks to be harmful for the network.
Yeah.
Yeah, as for me, I quite agree on all of the mechanics. I mean, having caps and limits to prevent situation being out of control. However, for withdrawals, in particular for Lido, there is the concept of bank mode was introduced. Basically, it allows to not pause, but make withdrawal process more lengthy when mass slashing happen, because it's a visible first move advantage to run out of protocol if like slashing happen and you expect that the token market condition would be worse. So that's why, yeah, being hard means being extra cautious and have a variety of safety nets. Yeah.
Yeah, I think that's actually an interesting point. There have been some discussions about changing the mechanics of the queue in order to prevent, I think, essentially Lido's dominance. Would be curious to hear your guys' thoughts on whether that's. I think I've heard people argue it's actually more harmful, potentially. Some have argued it's less harmful to the security of the Ethereum network. Would be curious to hear your guys' thoughts on that, on this proposal.
I'm not sure if it's gonna work actually, because probably like, okay, if there is one protocol that is suppressed in size, then there could be like some other protocol that will grow like later, and then you have to like swap from like decreasing the size of one protocol to decreasing the size of another protocol. So I think like we had similar situation with consensus clients, where like Prism client grew like too large. Most of the validators were running on them, and it was actually so yeah, I think right now the situation is much better, where the like not on the execution layer, but on the consensus layer, where clients are almost like equally used. So I think maybe like something similar can be achieved with other let's say protocols like liquid staking protocols, where there is like more granularly distributed stake, to let's say not having like multiple protocols holding like all of the stake.
Yeah, it's a hard question actually, because like I'm here talking about Lido share and like have maybe some bias. I mean, it's okay, but still, if possible. So for self-limiting, I agree that it's a thing that could work for a particular protocol, but it's not scalable thing, and no one can guarantee by consensus rules or whatever else that the next player would play that game at all. Yeah, and that's why actually before voting on self-limiting proposal, there was quite lengthy discussion where actually it's one of the most diverse topics on Lido Research Forum that had happened. I mean, so many participants from various parties, stakeholders, and participants. Well, the risk is true. I mean, the risk of having the protocol with too large Ethereum participation. For us currently, the mitigation path is to have dual governance implemented. Dual governance in our case means STF veto mechanics. When LIDA proposal of LDO holders can be objected by STF holders. So we suppose that it could help to cope with this problem. However, like it's an experimental thing, yeah. So let's see.
Speaking of experimental things, someone from the audience has asked about the ZK proofs to reduce storage costs, Eugene, and they're asking, has it already been used anywhere in the code bases, or is this still in the early stages?
Yeah, for us it's early stages. We have testnets with ZK data for oracles, but at the very beginning of 2024, we expect to have first mainnet setups, maybe.
I think that's a nice segue into kind of another topic, maybe a little bit more low level. You know, one of the reasons that people have talked about self-limiting is a governance thing, right? Which is like the governance maybe have, but there's another topic which is the sort of smart contract security risk, and you know, and just like you might have diversified consensus clients in case there's a bug in one, you should have, you know, multiple smart contract implementations. And I guess, you know, would love to hear the thoughts from each of you about how smart contract security and testing plays a role in each of the organizations and in an effort to reduce the risk there is a bug. Eugene, do you want to go first?
Well, for smart contract security risk mitigation, I suppose that the most important part is design. I mean, 80% of spec always is about corner cases and about expecting unexpected things. Moreover, we believe in advanced security measurements like formal verification. That's why we gone through it with Lido V2, and it was quite helpful. Well, I suppose that it could be a new security standard for the smart contracts to have like second layer of security by formal verification, actually.
Yeah, in our case, I think like also design is one of the key parts. We need to, like, every time we design a new feature, different parts. For example, the exit queue for V3 was pretty difficult one as well. But every time we design something, it's always you have to think about, like, not, let's say, the normal cases, but the actual, let's say, some tricky or unusual cases that can happen, like someone like with flash loans, for example, or something else that could be used. So we test a lot. We run like different kind of testing on our contracts, and and also we like, of course, like audits and security contests. This is something we do a lot, and also the testnets. We've been, I think, since February with V3 testnet, we've been like recreating them multiple times, like finding something, fixing, creating a new testnet, and it was like constant process of fine-tuning all the corner cases and problems that arise from just like running the protocol.
Makes sense. We've talked about a few different types of risks. One that we haven't talked about is maybe jurisdictional resiliency. With any bleeding edge technology, which I think liquid staking is certainly part of, you can sometimes come under the crosshairs of regulators or governments. How do you guys think about jurisdictional resiliency within your respective protocols? Dimitri, I think we can start with you.
Yeah, that's a good question, and I think it's like one of the questions that is really, there is no certain answer on it for now. Like there is really so many different opinions, but the actual kind of solution on how to like protect yourself, protect your protocol from that is not that clear. But in our case, we have like we provide a smart contracts layer. So we have like our model is somehow similar to, let's say, Uniswap model, where anyone can create a pool and provide liquidity for their tokens. In our case, you can come and let's say create a vault for running validators, staking, and also you don't need to mint liquid staking on top. That also is quite helpful for many protocols, or for many, let's say, institutional clients, where one of the most like regulatory part comes not from doing staking, but actually from minting the liquid token and trading it. So this is usually the difficult part. So, and also by like providing the features that allow different entities to, based on their regulatory requirements, to select the set of features they want from the vault. That's something that we wanted to do. If you are completely fine with like having your own liquid token, anyone can stake there and like utilize in DeFi, that's fine. You can create a like specific vault for that. But if you are more in a strict side where you have to run privately, whitelist the ones who can stake and not have a token, that's also possible. So we try to balance between, because we don't think there is like one solution for everyone, but there are like different solutions that based on your requirements you can choose and run with.
Yeah, I also agree on that, because speaking about protocol, the protocol is software thing that can do variety of things, and basically to fulfill your particular needs. I mean, whether you want the token that behaves like that, or whether it should be rebasable, or maybe you want to have validators that selected by the particular principle, like the vaults do. All of these actually are features, and having an opportunity to select them and to pick up everything you need, and otherwise leave something you are not comfortable is a way forward. Yeah, I agree on that.